Okay. Hello, everyone. Good morning. I'm Vincenzo Stoico, and today I'm from University of L'Aquila. And today I'm here to present our work that is called Software Model Refactoring Driven by Performance Antipattern Detection. As you know, software complexity is constantly growing, especially in particular domains. For example, in the space domain, in the figure that you see in this slide, I put chart that shows how the software complexity grown from 60s to 2010 for several space missions. And this domain is particularly interesting for our purposes because, for example, space aircraft, they usually execute and work in environments that are that can change. Sometimes they are unknown, and they have to execute for longer durations. So it's really likely that they will these systems will be subject to a change that can be a new requirement or a change of context. So refactoring the current system is really important. And in our work, in particular with our tool, we want to help the designer in the evaluation of the system after the refactoring, and in particular to evaluate the performance of the system after applying a refactoring. And for this purpose, we created a tool that is called Performance Antipattern Detection and Refactoring, PADRE, that has three main features. The first one is to detect if there is a performance anti-pattern in the system, but the system represented as a UML Marte model. What is UML Marte is one of the most used modeling languages, but Marte is an extension of UML that is the core language. Marte allowed us to annotate a UML model with semantics coming from the performance domain, but we will see this more deeply later. So the tool is the tool can identify if there is a performance anti-pattern in the representation of the system, and then the user, thanks to our to the graphical user interface we made, can decide to apply to the model a refactoring action. So after the choice, this action is made on the model, and we have a new design. We obtain a new model representing a new design that is evaluated. And for this purpose, the tool integrates a transformation from UML Marte to a performance model. And we will see in later slides. So this is the architecture of our tool of Padre that has been built using Eclipse Epsilon. There is a suite of tools provided by Eclipse. This suite includes languages and tools to work with models. You see that the main component of our tool, you can find all the main components in the big component called Padre. The most important one is the transformation one that is able to load what we call performance model resources. And you can think as performance model resources like all the resources related to a performance model. For example, a solver or XML files that are loaded into the model, and they are loaded to create an internal representation that then is used to run the transformation from UML Marte to the performance model. And then the solver is called and is executed to obtain performance metrics. Also, the refactoring component is really important because it includes the detection engine and the refactoring actions. For this purpose, we use the languages that are included in Eclipse Epsilon, and in particular AVL and EOL. And but the tool, especially the graphical user interface, has been coded using Java. It's mainly Java code. This is the workflow that summarizes the main steps that Padre executes. We start from a UML Marte model that is converted to a performance model. Then the solver is called and executed. we obtain performance values that are then annotated, reported back in the UML Marte model, and then the tool checks if there is a performance anti-pattern, and at this point, the user can decide if he's satisfied about the design or not to continue, so to apply a refactoring and then start again the loop, so evaluate the new design, or to stop. But as I was saying, the input of the tool is a UML Marte model that should have a precise shape, and the UML Marte model should be structured in three main views: the static view, the deployment view, and the dynamic view. In the static view includes all the components that are involved in the system and their connection. So you can think about this view as the architecture, the logical architecture of the system. Then we have the deployment view that contains all the physical resources of the system. In this case are represented by the boxes you see on the right hand side of the slide. And here you can see Marte, the extension of UML, where you see like the utilization. We used Marte, and in particular the class of Marte that is called GAexecHost, that allows us to include the utilization in a UML model. This is the dynamic view that represents an execution of functionality of the system. On the left-hand side, you have a scenario that is exploded in the sequence diagram that you see on the right-hand side. And this is really interesting because for each operation in the sequence diagram, for example, expired or get status, we can include and we can attach to the operation the probability that the operation will be executed and the number of repetition, number of times the operation will be executed. At the current status of the tool, we have implemented the transformation from UML to layered queuing networks. So we mapped the elements of UML to the elements of a layered queuing network, and you can see it's really simple. It's really trivial, the mapping. We mapped a lifeline to a task. A lifeline in a sequence diagram can represent a customer or a component or an instance of a component. A task instead represents a resource in a layered queuing network, and a lifeline can have different class of execution that are represented by this small rectangle under the rectangle user on the lifeline. And indeed, this is mapped to an entry that represent a different kind of service class of customer in a layered queuing network. For instead, the physical devices are mapped to the processors in a layered queuing network. This code is a Nebwell script that implements the detection and what are the refactoring action that are suggested to the detection of the anti-patterns, and what are the refactoring actions that are shown to the designer. And the detection of the anti-pattern is implemented by formalizing an anti-pattern as a first order logic formula, and you can see this formula under the label check. And then if this formula is satisfied, we show to the user all the refactoring action that he can apply to remove the anti-pattern and to improve the design. This was all. I have a small video, a demo of the tool that I can show you. Okay, this is the tool. This is the UML model. In our tool, this is the graphical user interface of Padre. What I'm going to show you is the interface.
It's not sharing the right screen.
Okay, I'm sorry.
So probably still on the slide and not on the video.
Yeah. Okay. Okay. I think you can see it
It's coming.
now, right?
Yes.
Okay. So this is the graphical user interface of Padre. This is a UML model. And now I'm going to show you where the user can specify the model in this configuration of Padre that is made by the user here. And then Padre, once loaded, shows what are the operation, the refactoring action, and we can choose between this one. In this case, we move this operation on a new node, and then the transformation is launched and the solver is called. So we have all the performance metrics, and you can see the new node here with the utilization that is being just calculated. Okay, now a new model, refactored model is created. Is this one. And yes, I'm going to show you, this is the new node that is created and the operation has been deployed on this node. This is the L1 that we obtain starting from the initial model. And this is like the product of the output of the solver that is like the L1 that has been solved with all the performance metric. And then we can continue the loop just applying new operations on the refactored model. We have again like the performance estimation, and you see that the tool created a new node because we told it to create a new one. I think that's it. That's pretty much all, because I was applying another operation in the video, but I think it's enough to these are the features of Padre. So I think like for me, like the presentation is finished. If you have any question, it would be nice to